Welcome back to Mysteries Mysteries. I'm Mystery Scholar and this is Episode 2, Fibonacci's Biggest Secret Part 2. By clicking on the link in the description below, you can download the entire episode for just 99 cents and join me as I take a look at the following mysteries. First, we will pick up where we left off in Episode 1, viewing the Mobius Fibonacci sequence through specific lenses in number theory. These mod math lenses reduce the Fibonacci sequence to a Mobius cycle. Once we have a common understanding of mod math, we will view the Fibonacci sequence through a pentatonic lens and discover how I compose the fifth chamber, the beautiful and meditative track playing in the background now. Finally, we will move on to the ninefold human. After introducing some Rosicrucian philosophy, we will go through the composition of this mod 9 track, and you can hear the ninefold human playing in the background now. While you listen to a quick harmonious sample of ninefold human, please enjoy a short series of snapshots of my website. This is where I offer videos and materials on mathematics, science and experiment, philosophy, sounds and music, tutoring, test prep, workshops, natural living, and more. Head over to www.mrescholar.com to learn more. While you're at my website, check out the 2 therapeutic music albums I composed. Solfeggio Grooves is a dance album based on the solfeggio tones arising from the Fibonacci sequence, loaded with didgeridoos, shakers, binaural beats, and digital accompaniment. Available now on Bandcamp for just $5 or 99 cents a track. Fibonacci Cycles is the album consisting of both fifth chamber and ninefold human, composed directly from the Fibonacci sequence. This album is also on Bandcamp and is available for $3 or 99 cents a track. And now back to our episode. In order to fully understand the fifth chamber, we have to dive into the Mobius nature of the Fibonacci sequence once more. In this way, we have to recall modular mathematics. I invite you to return to episode 1 if you'd like a deeper refresher, but for now we'll have a quick little review of modular mathematics. Modular mathematics asks us to look at cycles of a certain length in the non-negative integers. So for example, we're going to consider a cycle length of 5 for the fifth chamber. So we have a cycle length of 5, and that means we're going to look at the non-negative integers and essentially group them in cycles of length 5 sequentially. So we're going to look at cycles that are essentially 0, 1, 2, 3, and then 4. Notice we stop at the 4 because that is the fifth member of this cycle. Essentially what we're doing with modular mathematics is looking at the number of whole groups of a certain number that can fit into the number in question. So for example, let's look at this list of the first few, or the first 14 non-negative integers, and consider the cycle length 5. What we're going to do is repeat this cycle length through the non-negative integers ad infinitum. So essentially 0, 1, 2, 3, 4. That's our first cycle. Now we essentially repeat that cycle. 0, 1, 2, 3, 4, and so on. 0, 1, 2, 3. This now encodes the non-negative integers into a modular math lens, or according to this cycle, we're looking at the mod, or the modular operation of these certain non-negative integers. So to answer the question of what this actually does for us, we can look at the non-negative integer, say 9, and see that 9 is actually congruent to 4 mod 5. And so we can see that 9 has only one whole group of 5 with 4 remaining, and thus 9 is congruent to 4. Looking further, we can see that 12 is congruent to 2 mod 5, because 12 has two whole groups of 5, 10, but then 2 remaining, so 12 is 2 mod 5. We can then extrapolate this to an integer that is not listed, so for example 41 is congruent to 1 mod 5, because 41 has 8 whole groups of 5 up to 40, with 1 remaining. And so if we were to carry out this cycle of 0, 1, 2, 3, 4 ad infinitum, we would see that 41 would reduce to 1 mod 5. And essentially this is the whole operation of modular mathematics. And this is the lens at which we're going to look, or through which we're going to look at the Fibonacci sequence. So here we have the Fibonacci sequence listed up to the term 610. And we're going to use the mod 5 operation on the sequence. So for the first few, it's quite simple to see that 1, 1, 2, and 3 all remain as they are. But if we recall, 5 became 0, and so did 10, and so will 15, and so will all numbers that are divisible by 5. And so this 5 in the Fibonacci sequence becomes 0 with the mod 5 math lens. Now let's look at 8. We see that 8 is in our list, so we can obviously see that it's 3, but we know that 8 has one whole group of 5 with 3 remaining, and thus 8 becomes 3 mod 5. The same holds for 13. We see that 13 reduces to 3 mod 5. 21 would be 1. 34 is 4, because again, 34 has 6 whole groups of 5 up to 30, but with 4 remaining, and thus 34 reduces to 4 mod 5. Here we have 55 is obviously divisible by 5 and becomes 0. Now I can stop there because I already know the recursive definition of the Fibonacci sequence. The recursive definition says that we start with the first two terms, we sum them together to get the next term of the sequence. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. However, if you recall in episode 1, we showed that the recursive definition holds in the mod math lens. So we can actually go ahead and return to the Fibonacci sequence with the recursive definition using what we have already with the mod 5 reduction. So we can actually see that over here at the beginning. 1 plus 1 is 2, obviously. 1 and 2 is 3. 2 and 3 is 5. 5 is divisible by 5, which reduces to 0. Then again, 3 plus 0 is 3, of course. 0 plus 3 is 3. 3 plus 3 is 6, but of course 6 has a remainder of 1 mod 5. 3 plus 1 is 4. 1 plus 4 is 5, which reduces to 0. So we see the recursive definition hold. So let's go ahead and continue with that up to our term 610. So 4 plus 0 is 4. 0 plus 4 is 4. 4 plus 4 is 8, which we know reduces to 3. 4 plus 3 is 7, which is 2. 3 plus 2 is 5, and I get a 0 for a 5. Now, we can check this quickly. 233 is obviously divisible by, actually has whole groups of 5 up to 230, with 3 remaining, so we have a remainder of 3. So that is the Fibonacci sequence up to this term 610, but what happens from there? So let's check out 2 plus 0 is going to be a 2. So we can go ahead and look at this and know that it's going to cycle forth as we saw in episode 1. So I already know that I'm going to have some sort of a finite cycle or a loop, as I saw in episode 1. And if you'd like to go ahead and continue out this Fibonacci recursion, you can with a list, or let's go ahead and turn to a cycle. So I already know the cycle length ahead of time. It's going to be a cycle length of 20, but you can go ahead and list it out linearly if you'd like on your paper. But I'll turn to the cycle. So I'm going to go ahead and list my zeros with red. So I have a 0, and then I have a 1, 1, 2, 3. 2, 3. And then I have another 0 here at this 5. I'll go ahead and highlight on my board what I'm talking about. So all my zeros become red. And then I have 3, 3, 1, 4. And another 0. Oops, it's a little bit like a G. Let's put that as a 0 there. And then we have 4, 4, 3, 2, and another 0. So 4, 4, 3, 2, and then a 0. Now, I don't have room on the board to continue the recursive sum, but let's go ahead and do that in the cycle. So we had 3 plus 2 is 5 is 0, then 2 plus 0 is 2, 0 plus 2 is 2, 2 plus 2 is 4, that needs no reduction, 4 plus 2, or 2 plus 4 rather, is 6, which reduces, we know, to 1. And then 4 plus 1 is 0, giving us our 5 once more. Now, what would happen after that 19th term in the Fibonacci sequence? We see that the 20th term becomes 0, then the 21st term would have to reduce to 1 once more, since 1 plus 0 is 1. The 21st term is 1, the 22nd term must also be 1, and thus we see that after term 20, the Fibonacci sequence cycles once more. And again, I challenge you to find any number cycle length, any mod number that the Fibonacci sequence does not reduce in. Or, sorry, does not reduce to a cycle in. So I'm going to go ahead and highlight these zeros. And notice that they kind of segment the circle into 4 different sections. So in order to then construct the fifth chamber, I then thought that, well, we've got a cycle length of 5, and we've got these 4 sections that are very unique and pronounced. And so I had done some research in ancient Egyptian culture and was very keen on their use of the suspended pentatonic scale. And in the Egyptian suspended pentatonic, they start with a root of A flat, or you could see this as, what would that be, G sharp, and then it moves over to B flat, D flat, E flat, G flat. And these 5 notes make up the suspended pentatonic scale used throughout ancient Egypt. I went ahead and transposed that scale into A, C, D, E, and G. And so if you notice here, I've got 5 notes for the 5 notes in the scale, the pentatonic scale, and once again I have the Fibonacci sequence reduced into numbers, 5 numbers, 0, 1, 2, 3, and 4. So this is how I encoded my song for the 5th chamber. I declared 0 to be my root note D. And so 0 takes the place of 0 and 5. So wherever I see a 0 or 5 in the sequence, that's where I would play the note D. I then said E was note 1, G was note 2, and over here I've got A as being note 3, which is seen as negative 2. We'll write that in a moment, 3, and C is note 4, and I'm back to the 0. So 0, 1, 2, 3, 4 is exactly the cycle that I have. It is exactly the numbers that I have in the Fibonacci sequence reduction. So we can also see this as I was about to write in the negatives. I'll go ahead and write it in blue. We can see our 0 as being the root, and then we have 1, 2, and then we have negative 1. Actually, I should write this not with the hyphens. That's a little confusing. I use dots. So we have a 0, and we have 1, and 2, and then negative 1, negative 2, or commas rather. And so those would be the notes that I would assign. So A is negative 2, C is negative 1, and so on. And we can see that those negatives can be transferred over here. And I'm just going to write this out because some people have a background in Walter Russell, and this is a very Russellian concept. So we have 1, 1, 2, 3, but 3 is actually -2. And then it's -2, -2, 1, -1. And we have -1, -1, -2, 2, 2, 2, -1, 1. And so there's a benefit in looking at the sequence or the cycle in that way in terms of musical harmony. So having my root note as D, I have 2 notes above and 2 notes below, and so there's a little bit of a balanced harmony in the geometry of the tones. So that said, as I said before, I noticed that the zeros segment this cycle into 4 unique sections. And within sections, I noticed that there are 2 main concepts. There's the concept of the numbers that are present, and there's the concept of a number that's not present. So for example, in the first cycle, I have 0, 1, 1, 2, 3, but no 4. So I'm going to write no 4 in there. The next section I have 3, 3, 1, 4, but no 2. Next I have 4, 4, 3, 2, there's no 1. And next I have 2, 2, 2, 4, 1, and no 3. So I noticed that was pretty significant at the beginning, and I also noticed that we can look at the numbers that are present as numbers in total. So we look at the sum of those numbers. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 3 is 7, which becomes 2 mod 5. So I'll write sum 2. Here we have, now this is where the negatives kind of help and play. So we have a -2 is a -4, plus 1 is -3, minus 1 is a -4, which becomes 1. So 5 minus 4 is 1. And continuing on with the negatives as useful, so -1 and -1 is -2, -2 and -2 is -4, -4 plus 2 is -2, but -2 mod 5 really is 3. So sum is 3. And finally we have 2 plus 2 is 4, minus 1 is 3, plus 1 is 4. So the sum is 4. So now notice though that in each section there's something unique happening. The sum and the missing number are unique. 4 and 2, the sum is 2 and 1, 1 and 3, 3 and 4. So we have a unique distribution of the 1, 2, 3, and 4 throughout the 4 sections. One final thing that I noticed was unique about this lens of the Fibonacci sequence using the mod 5. We have at the start of each section a tripling sequence. 1, 3, 4, 2. So how is that tripling? Well, let's look at the tripling sequence as it is. So tripling means we start with 1, triple, multiply by 3, we get 3, multiply by 3, 9, multiply by 3, 27, 81, and so on. That's the tripling sequence. But let's look at that through the mod 5 lens. So we have 1, 3, 4, now 27, 25 is the largest number divisible by 5, less than 27, so 25 is 2 away, so 27 is congruent to 2. 81 is clearly is a 1 mod 5, and so here we see the cycle started over again. So 1, 3, 4, 2, multiply by 3 would be 1, or 1 times 3 is 3, and so on. So our cycle really is 1, 3, 4, 2, and so on. 1, 3, 4, 2, and so on. And so that is how the Fibonacci sequence reduces mod 5, and this is how I constructed the 5th chamber. I just simply used this transposition of the suspended pentatonic scale used in the Egyptian culture, transposed to the white keys there, and I chose then the D as the root, 0, and so essentially I then had marked in the transposition or the letters there, I'll just go ahead and use black here. So D is 0, so D, and then E is 1, D, E, E, and then G is 2, and A is 3. And then back to D here on the 0. So the only difference I did with, instead of having just 5 notes, I actually included 6 notes by having an upper octave to the D. So here it starts on the lower octave, upper octave, lower octave, upper octave, and so on, and just cycles through. And that is how I created this track called the Fifth Chamber, and I hope you enjoy. Alright, welcome back to the episode. I sure hope you enjoyed the fifth chamber. Now let's turn to the ninefold human and see how I constructed that track using, again, the Fibonacci sequence and now a Mod 9 lens. Now again, refer to episode 1 if you'd like to see more about how the Mod 9 lens applies to the Fibonacci sequence, but you'll see the end result here in this episode. So again, we have the Fibonacci sequence, 1, 1, 2, 3, and so on, up to the term 144, which seems to be Leonardo Pisano's key number. And as we saw with the Mod 9 reduction, that was the key number for seeing this cycle complete. So as we saw with the episode 1, the Fibonacci sequence reduces Mod 9 to 1, 1, 2, 3, 5, 8, and now 4, 3, 7, 8, and 9. And so again, recall that 9s become zeros, and here we have the interesting relationship of the 3s, as we saw with the episode 1 with Tesla mentioning 369 being something to do with the universe. And so in the end result, we saw this Star of David figure identifying the 3, 6, 9 triangles, which then again, if you recall from episode 1, gave us the solfeggio tones, which were deeply rooted in sound healing and biblical references. So as we did with the fifth chamber, let's look at the Fibonacci sequence through this Mod 9 lens and look at the sums and missing numbers. So recall episode 1, this cycle really has two parts, which we kind of drew the yin-yang symbol to represent the positive, negative halves of this cycle. And we saw that in the first half of the cycle, we have all of the representations of 0 through 9 except 6. So we had no 6 in the first half, and then likewise in the second half we had no 3. Now let's look at the sums of these numbers here. But before I do, I'm going to look at how the positive-negative relationship appears in this Mod 9 cycle. So again, let's look at the Mod 9 cycle really is 0, which is our middle, and it goes up to 1, 2, 3, and then 4 is about as high as it goes because the negative 4 is actually 5. So we have negative 4, negative 3, negative 2, negative 1, and we see that this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 becomes 0 again. So I can see that 5 is negative 4, 6 is negative 3, 7 is negative 2, and 8 is negative 1. And I'm going to go ahead and insert those positive-negatives relationship into this cycle, which will help me compute the sums a little quicker. So we have 1, 1, 2, 3, and then negative 4, negative 1, and then 4 is fine, 3, 7 is negative 2, and 8 is negative 1. Now going over to the other half, negative 1, negative 1, negative 2, negative 3, 4 is fine, 1, 5 is negative 4, 6 is negative 3, 2, and then 8 is negative 1. Now again, I'm just doing this because it will help with my sums. You're welcome to do it however you wish. Just go ahead and sum the first half and then reduce that number Mod 9. I'm going to just go ahead and sum Mod 9. So 1 plus 1 is 2, plus 2 is 4, plus 3 is 7, minus 4 is 3, minus 1 is 2, plus 1 is 6, or sorry, plus 4 is 6, 6 plus 3 is 9, which is 0 again. So now we're at negative 2, plus 1 is negative 1, and negative 1, and negative 1 is negative 2. So we see that the sum is 7, which is negative 2 in the first half. Now, I know that the second half is exactly the negatives of my first half, so I can go ahead and assume that the sum is going to be 2, since that is the negative of 7, Mod 9. But let's go ahead and verify that, just so that we're all practiced with this concept of adding positive negatives in a mod sense. So here we have negative 1 is negative 2, plus negative 2 is negative 4. Negative 4 plus negative 3 now is negative 7, which is actually 2. So 2 plus 4 is 6, plus 1 is 7. 7 minus 4 is 3, 3 minus 3 is actually 0. And we start over again just like we did before. 2 minus 1 is 1. 1 plus 1 is in fact 2. So our sum is 2 as we assumed it would be. So here we have no 6 on the first half and a sum of 7. Here we have a sum of 2 on the second half and no 3. One last thing I added to the ninefold human track was actually adding in sums of the smaller sections identified by the triangles. So we have 1 plus 1 is 2, plus 2 is 4. So I'll just write a 4 in this little triangular arc section. We have 5 plus 8 is 13, which is actually 4, and 4 plus 4 is 8. So we have an 8 here, and so on. So 7 plus 1 is 8, plus 8 is 16. 16 is really 7. So let's go ahead and now look at the negatives, because again, for me, it's a little easier. Negative 1 and negative 1 is negative 2. Negative 2 and negative 2 is negative 4, which is a 5. And then we have the sum over here. 5 plus 1 plus 4, that's actually just going to be a 1. And here 2 plus negative 1 is negative, or positive 1, plus 1 is 2. And so I wanted to highlight that because again we saw the doubling sequence appear in episode 1, but here we have it again. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, which reduces to 7, 7 times 2 is 14, which reduces to 5. 5 times 2 is 10, which again reduces to 1. So interestingly enough, starting over here in the second half of the second section is where we have the doubling sequence. Anyhow, I just identified those sums there because again, I inserted those in the track ninefold human. So the whole track has a drone behind it, the drone being the 0. So if you listen to this track coming up, you'll hear a drone, and that's the 9 tone. And then I play 4, 8, 7, 5, 1, 2, these 6 sections of these sums. And then once I cycle through that once, I then go da 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 da, and so on. You'll hear it in the track coming up in just a moment. So again, the 9 drone in the back, the sums per section changing behind those sections as those sections are highlighted. So as the notes 1, 1, 2 are played, the drone 4 is played behind it. And then of course we have the 8 and the 7. And so and then on the first half we have drones of 6 and 7, second half drones of 3 and 2, and so that is exactly how I constructed the ninefold human. Like in the fifth chamber, I needed some sort of structure, a musical structure, to identify the numbers with. And so here I have actually 9 numbers, and I didn't really know of any 9-note scales that were popular. Obviously, the common chromatic major scale has 8 notes, or actually 7, with the 8th note being the octave. So I needed to find some sort of 7 relationship. And at the time, I happened to be learning some Rudolf Steiner, and Rudolf Steiner is heavily influenced by Rosicrucian philosophy. And so in the Rosicrucian philosophy, they talk about our being, our human being, as actually a ninefold form with 3 sections made up of 3 subsections, so physical, mental, and emotional sort of concepts. And we'll see this in a future episode in the philosophy section, so stay tuned for that. But Rosicrucian philosophy played a heavy impact in Rudolf Steiner's concepts, and of course, as I was learning Steiner, I then had this influence from the Rosicrucian philosophy. And in their philosophy, they do talk about how there are 9 aspects of the human, and so there's 3 levels, and within each level there are 3 aspects. And although they talk about these 9 as being the fundamental aspects, they do identify 2, they make 2 identifications. So for example, they say these 2 are similar, or they talk about it, the analogy is like a sword and a sheath, or a hand and a glove. If you have the 2 present, does one really make sense without the other in the term of the relationship? clearly a glove and clearly a hand have independent uses and independent definitions. However, in terms of the definition of a hand going into the glove and a glove being used to wrap a hand, either don't make a sense without the other. So that's how they kind of make these identifications within the realms of the certain aspects of our being. So for example, they make those identified, and then they say these are identified. And again, their analogy is like a sword and a sheath. What's a sheath really makes sense without a sword, and a sword really is a dangerous thing without a sheath. So it kind of holds it and contains it in a safe manner. So the Rosicrucian ninefold human, they make two identifications of these separate entities individually, and thus 9 becomes 7. So here we've got this red circle really is one thing, and this red circle is one thing. So let's count 1, 2, 3, 4, 5, 6, 7. And so by making this correlation to the Rosicrucian philosophy of a ninefold human reducing to 7 aspects, I then had the key to making the relationship of those 7 aspects to notes, and those notes then to the 7 main aspects here. Because again, we have no 6, and the 9 is really this divider. So in this first half, there really are just 7 notes being played. And likewise, in the second half, there are just 7 numbers, 1 through 8 with no 6. And so that is how I then composed the ninefold human track. And here it is coming up, and I hope you enjoy. thanks for joining me on this journey. I sure hope you enjoy the music, and I hope you learned something as well. Please check out future episodes, including Chaga, How to and Why. I'll have a whole unit on cymatics, and then an episode on St. John's wort remedies and more. I'm also offering tutoring on Zoom. Check out my website and find out more. Happy learning!